Hello students, welcome to my study channel. Today we will study on rational numbers. You see, this is for rational numbers. Zero is called the additive identity. Additive identity. You also know it for the integers, but now you should know zero is also called the additive identity. You see, additive identity, when you will add again, there is some equality, that means there is some identity, there is no change. How you see, you may take any positive or negative rational number, that doesn't matter. Suppose I will write minus 2 upon 3 plus 0, that is equal to minus 2 upon 3. So you see here 0 is called the additive identity because there is no change. You see, there is no change in the sum. So 0 is called the additive identity. You may take 2 upon 3 plus 0, that is equal to 2 upon 3. Or you may take 2 upon 3. If you write first 0, then you add minus 2 upon 3, that doesn't matter. Again the sum is minus 2 upon 3. So there is no change in the sum. So 0 is called the additive identity. Just to remember it. Next, like that 1 is called the multiplicative identity. Okay? You also know it for the integers, already we have discussed, and also for the whole numbers. And you see, suppose minus 2 upon 5 into 1, that is equal to minus 2 upon 5. You multiply any rational number by 1, you will get the same rational number. No change in the value. The numerical value is same. When you multiply the rational number by 1, so 1 is called the multiplicative identity. You may write 1 first, that doesn't matter. Again the product is minus 2 upon 5. Because this is the commutative property. Add the rational numbers, so commutative property, or they show commutativity under multiplication also. And we should know about the multiplicative universe. Please focus on it. Multiplicative universe or reciprocal. Multiplicative universe or reciprocal. We will know about it. You see, for the rational numbers, you see, if the product of two rational numbers if the product of two rational numbers is 1, then both are the reciprocal to each other. Both are reciprocal of each other. For example, suppose I will take 2 upon 5, it is a rational number, and I will multiply the other rational number, let it be 5 upon 2. And what will the product here? You see, numerator into numerator, denominator into denominator. Then by the common factor you divide both the numerators and the denominators. You see, the product is 1, already you know. So you see, here it was one rational number, it is the other rational number, and the product of two rational numbers is 1 here. Then 1 is called the multiplicative inverse of the reciprocal of other. That means 2 by 5 is the multiplicative inverse of 5 upon 2. Or 5 upon 2 is also called the multiplicative inverse of 2 upon 5. Both are reciprocal to each other. So the multiplicative inverse, if I write in short, suppose multiplicative inverse of 2 upon 5, that is equal to, just you bring the denominator into the numerator and take the numerator to the denominator. What will be? It will be 5 upon 2. And multiplicative inverse of, suppose, minus 3 upon 7, that is equal to 7 upon minus 3, or you may call minus 7 upon 3. Both are right. So most important is multiplicative inverse of a non-zero rational number exists. So if A upon B is a non-zero rational number, then its multiplicative inverse exists, otherwise not. So A upon B is a rational number and it is not equal to 0, then its multiplicative inverse exists. So the multiplicative inverse of A upon B is equal to B upon A. So remember, 0 is a rational number or not, but its multiplicative inverse never exists. So 0 has no reciprocal or no multiplicative inverse. Because if I write 0 is equal to 0 upon 1, then I cannot write 1 upon 0. It is undefined. It is not defined. We cannot divide a number by 0. 0 cannot be the divisor. It is meaningless. It is not defined. Okay? Today we will study about the representation of the rational numbers on the number line. So I write here representation of rational numbers on number line. So we will take some examples of the rational numbers. Suppose 2 upon 3 minus 2 upon 3, 3 upon 2, suppose minus 5 upon 2. Just we will represent the rational numbers on the number line. So how I do it, just focus. So use the ruler first, and using the ruler you press You will represent a line first. Give a mark on it. Label as 0. Then suppose we will have to represent 2 upon 3. So first you will have to mark numerator is less than the denominator or not, or numerator is greater than denominator. You see here numerator is less than the denominator. So you see it is like the pattern of proper fraction. It seems yes or no? So you see we will have to take 3 equal divisions and we will have to take 2 out of it. So we will have to take 3 equal divisions. So for each equal division we have to take a length that will be fixed length. You will have to take on your own from the measurement of your ruler. And suppose you decide when you are dividing one object or one length, you are dividing it into 3 equal parts. So each equal part is 1 upon 3, yes or no? So for the number 1 upon 3, because you have to take 3 equal divisions and each equal division that will be 1 upon 3, and each equal division is equal to, suppose you take, it will be better for you, 1 centimeter of your ruler. So you take a fixed distance, that is 1 centimeter, and that is each equal division. So you see numerator is less than the denominator, and I have to take 3 equal divisions, and my each equal division that is equal to 1 centimeter of your ruler. So after taking 1 centimeter, you take a second point. Yes or no? So this is 1 centimeter, and you see how many points you have to take, how many equal divisions, 3 equal divisions. You take 3 equal divisions. This is 1 centimeter, next 1 centimeter, next 1 centimeter. And you see, this is your 1. How? You see, already you have taken. First you have not taken from 0 to 1. No, do not take like this. First from this you decide how many equal divisions? No, 3 equal divisions. So each equal division you took as 1 centimeter from your ruler. So 1 centimeter, 1 centimeter, then 1 centimeter. Then this 3 centimeter of length, that is your unit distance. Here unit distance is 3 centimeter. It will be easier for you because you already 3 divisions are here. So this is 1 upon 3. This is 2 upon 3. And this one, this is 1. This is 3 upon 3 or not? Which is 1. And we have to take 2 upon 3. So this point is 2 upon 3. You may show like this. This point is 2 upon 3. So next we have to move minus 2 upon 3. You see, the same divisions are there. We may maintain this number line. You see, 3 equal divisions. But here the minus sign that indicates we will have to move towards left of 0. So how will you go? The 3 divisions, and we have taken each equal division is equal to 1 centimeter, but we will have to take it towards the negative direction, towards the negative side of the 0. 3 divisions you take 1 centimeter each, and this is your minus 1. Already you have taken. This is minus 1 upon 3. This is minus 2 upon 3. This is minus 3 upon 3, which is minus 1. Already we have taken. So this point is minus 2 upon 3. So already we could solve here. Then you see, we will do, we will represent this number 3 upon 2 on the number line. You see, using ruler like this. Mark a point, label it as 0, and we have to create the unit distance. And you see here numerator is greater than denominator, or here it was numerator was less than the denominator. Here numerator is greater than the denominator. So what do we do here? Now you see 3 upon 2, that is equal to 3 into 1 upon 2. 3 into 1 upon 2. So 1 by 2 or 1 upon 2 or 1 divided by 2, that number is added 3 times to itself. So we have taken like this, and we see the number half. Let us take that is the 1 centimeter of our ruler. So first 1 centimeter, how many 1 by 2? Now 3 times I have to take. So this is 1 by 2. So how many 3 times? So next 1 centimeter. So 1 by 2 plus 1 by 2. That is 2 by 2. And you see this is 1. And then 1 by 2. And how many 1 by 2? Now 3 1 by 2. Already 2 1 by 2 we have written towards right. Next 1 centimeter, that is 3 upon 2. And if I next move 1 centimeter, that will be 4 upon 2. That is 2. So we could represent this. And in case of minus 5 upon 2, like this you do. You take minus 5 upon 2, that is equal to minus 5 into 1 by 2. So 5 times 1 by 2 we have to be added in the negative direction. Okay? So you see, and each number 1 by 2 or 1 upon 2 is equal to 1 centimeter of our ruler. Yes. So how many? Now 5. 1, 2, 3, 4, 5. 1 centimeter each. So this is minus 1 upon 2, minus 2 upon 2, which is minus 1, minus 3 upon 2, minus 4 upon 2, which is minus 2. And this is minus 5 upon 2. And next, if you take 1 centimeter towards left, this is minus 6 upon 2, this is minus 3. But we have last here minus 5 upon 2. So this point, you can circle it. So this point. So this is the representation of minus 5 upon 2. So we could discuss the representation of rational numbers on number line. Okay? So you take its photograph and erase it. Let us discuss about the rational numbers in brief, just to mark what I knew. We first name natural numbers. Yes. Then whole numbers. Then integers. Then we added some fractions, decimals, decimal. But you see, and we name over the rational numbers. But strictly you see, you write natural numbers, whole numbers, integers, fractions, and we also knew rational numbers. And you see, we could represent these numbers on the number line or not? Yes. And you see, 1, 2, 3, -1, -2, just these are the unit distances. This distance is equal to this distance, the length of this distance is equal to this distance, and these are the unit distances from 0 to 1, from 1 to 2, from 0 to -1, like this. And you see, 1 is a rational number, 2 is a rational number, and if I take here just a midpoint, this is 3 upon 2, like this. So we could show the natural numbers, whole numbers, integers, and also fractions, also rational numbers. And also in the higher class you will study about the irrational numbers, which are not rational numbers. That means we cannot write these numbers in the form P upon Q, numerator upon denominator. We cannot write like this. But these are also numbers. These are the irrational numbers. But they also exist on this number line. You will read it later. How you see? Just for example, I am telling you. I take it here. So this is 1 and this is 2, the fixed distance. These are the unit distance. From this to this, from this to this, the length is same. And you see, irrational number we can also show here. How? Now you see, this length is 1 unit and this you just construct a perpendicular here at this point. And you take this unit distance, the same length here. And you see, using the ruler just to connect it. And is it? Hello? It's a right triangle. And this is 90 degree. And this is called the hypotenuse. And here you see, what is h? H is root 2 unit. Because it is 1 unit. It is 1 unit. And you know, h is equal to root over p square plus b square. B is the base and p is the perpendicular. So here this length is called the perpendicular and this length is called the base. So this length is called the hypotenuse and that is root 2, which is an irrational number. So with the help of the compass, you place the metallic end of the compass here at the point 0 and you just move it like this. It will cut here just nearly, just equal to midpoint 1.5, just here first, and you just O be the center, and this h distance, that is root 2, automatically you take with the help of the compass and you just draw an arc and we intersect this number line here. So this point is root 2, which is an irrational number. You will learn it in the higher class. In the 9th class you will read it. And my point of saying is, you see natural numbers, whole numbers, integers, fractions, rational numbers and irrational numbers. All these numbers we can show on the number line. These are realities. So all these numbers are called real numbers. Reality, we can show it, we can represent it on the number line. And in the higher classes, you will imaginary numbers. These are, you now know it, you wait up to the bus and just fill in for the next class, higher class, you read about the irrational numbers. So all these rational numbers and the irrational numbers can be represented on the number line. So thank you for watching my channel, and if you have not subscribed, then I must wish you have to subscribe. So thank you. We will meet in the next class.